So I want to record a quick video by popular request on some of the post-processing tasks you can do in Paraview. So we open our case file. Let's start with the coarse mesh here, and we need to select the .foam file for OpenFoam, which will load the case in. I have reconstructed the case, as you can have seen in the video, post-processing data on the cluster. So we have the case reconstructed, not split to the different nodes. So I can now load that case. I want to load all the mesh regions, and I want to load all the different properties that we created. So we have wall shear stress magnitude in there, etc. And the time steps will start from 5.01 to 6. The averaged values will only be on the final time step. So I go to the final time step, and this is the one that will have the averaged values. Keep in mind that all the others, velocity, pressure, wall shear stress magnitude, will be the momentaneous values at time 6 seconds in this case, and the TA values will be the time averaged ones. And then in addition to that, we have transverse wall shear stress, and we have OSI, and we have RRT as the wall shear stress derived metrics, which were calculated by Hemo Postprocess. So if I, for example, want to plot the time averaged wall shear stress on this, then I see this plotted on the wall now. So the time averaged wall shear stress magnitude, I can rescale that, and I see low wall shear stress in the bulbous region here, and high wall shear stress where we have the impacting flow on the apex and on the inside of the branching. As we would expect, we will have a short region of very high wall shear stress as the profile develops again, but on average the wall shear stress is somewhere around 5 on this, which is 5 pascals, which is reasonable. The very high wall shear stress reaches up to into the 50 Pascal region here. So that's one thing that you can do. You can then visualize wall shear stress. You can visualize OSI. So we see high OSI values here in the separation region. Well, here we have a small bulb as well, so we have some separation there. And then here where we have the horseshoe vortices developed on this bulbous branching. So we see a structure where we will have separation flows, vortical flow, and that is characterized by high OSI. So this is the simple visualization. I now want to go into some of the more advanced techniques. And one of these is plotting graphs of the wall shear stress over time. And I want to walk you through how you can plot the average wall shear stress on this region of the sinus. So we usually use filters in pipelines. So in this pipeline window here, you will see the whole pipeline as it develops, as you do your post-processing. So I will add one filter which extracts regions. It's called extract block. And I select the sinus for this. And I give it a name so I don't get confused. So this is now only the sinus. On here, I can switch different things on. So this now has P on it. So if I want to make that blend in, I want to select the same things, the same property to visualize. So now I have this selected in its individual part. So what I now want is the average of that, and we have a filter for that as well, and that is integral values, integrate values. So that is now integrating whatever I selected, is integrating all the values over this part, and I want to say divide cell data by volume, and then apply. Go to cell data, which is this is important. The point data can't be integrated by volume specifically. So one of the things to look out for, you want the average hematocrit to be about 45 here. So time averaged wall shear stress magnitude on this part on average is 2.74. The averaged OSI is 0.05. So we can now look at the average values over this part. And if you go, and this only works on the final time step because we only have the time averaged values there. But if you go to a different time step, you see the other values here. So wall shear stress magnitude is here 0.82 on that level 6. So, but make sure that you stick to the final value if you want to look at that. So I go to the first value and see what the wall shear stress magnitude is. It's 1.21. And go in here, rescale that, or need to go to the sinus, rescale that. You see the OSI is not in that time step 5.01. So we need to select something different, for example, the wall shear stress. And here we see the wall shear stress in the first time step. And then we can walk through that. We need to rescale that a little bit. So now we can play through the wall shear stress here and see how the wall shear stress develops in that sinus. You see what that looks like. You also see the values change here, wall shear stress magnitude. And I want to plot the wall shear stress magnitude over time now, as you see it developing here. So in order to plot the wall shear stress over time, I stop the animation. I select this line, make sure that it's cell data, make sure that it's divide cell data by volume to get the proper averages and not the integral times the surface area. And then we add another filter, which is plot selection over time. So we can select that from here. Plot selection over time. But this is one of the filters that's out also in here. Plot selection over time is also one of the filters that's in this filter selection panel. So plot selection over time. I say I don't only want to report selection statistics, so I switch this off and then I say apply. This will now read all the time steps, so depending on your case size that might take a while. On the coarse mesh this shouldn't be too long. It will complain that the number of components don't match, which is the case because we have more values in the final time step where we have the time averaged data. So I can disregard that. And you get a chart window here, which tries to plot everything that you have. If I select that window and select this plot over time thing, I can select what I want to plot. So for example, I deselect everything now and I want to plot the wall shear stress magnitude. Then that will plot that. You see that it will plot something different on the final time step size. That is because it's running by IDs, and the IDs will change when you have additional values. So that means we need to use bottom axis, use custom range, and we only plot to 5.99. And left axis, use custom range, and we want, because we see this goes down to some very high value here, so that won't work that way. So I need to think, what is the time step maximum? So the minimum should be 0 and the maximum, let's say 10. Yeah, there we are. So this is the wall shear stress over the time as it is plotted, as it is averaged over this part. I can now create a second part. So let's say I want the wall shear stress over the apex. So that's another extract block. I want this block to be the apex, for example. And then I do the same, add filter, integrate variables, divide cell data by volume, apply, which creates me a new one, a new table view, say cell data, select this, plot selection over time, switch off the only report selection statistics, and click apply. This will now read again all the data for the apex. And it will complain. We'll create a new chart view, which I switch off because I don't need those. I can switch off the two spreadsheet views as well. So this is my chart view now. I click this and I click this. I now can switch this one on and it plots both selections in the same window. I can now switch these off and put the wall shear stress magnitude on, and that will have plotted that. This is up here, so I need to change the scale here. So let me see how far this goes up. This goes very high up in this region. I think we said we go up to 50, or we go up to 60 even. So you see these two curves now. Well, unfortunately, Paraview gives it colors that are coded by the property, and they will be the same colors for the two selections here. So I need to change that manually once. So I can go in here, for example, and choose a nice green for the wall shear stress magnitude here, and give it a different name, wall shear stress magnitude apex, and go in here and say wall shear stress magnitude sinus. And now this is a decent plot. I can switch the carotid on, switch this to wall shear stress, switch this to wall shear stress, and this to wall shear stress, and can now have, for example, let's have a look maybe from this direction. and go to the first time step and play through. So you now get a nice animation where you see the wall shear stress developing here in the left-hand side, and you see the location indicated by this bar. So you see how that develops together. One thing when you do visualizations in Paraview, please don't use the screenshots because the quality of screenshots in reports is usually terrible. Paraview can export screenshots itself. So this is not a screenshot that is taken from your shot, but it will take, for example, I do WSS over time .png. I will write out this graph, and I usually go for twice the resolution because that gives me a nice resolution to play with on the when I scale these graphs. I can also write this out, save screenshot, onto a WSS, then go ×2. And if you want to write both out at the same time, so if you have a nice array of graphs and you want to keep that in one, then you can do both panels in this case. Okay, and you say save all views, and that will give you this whole panel. You can also say save animation, and you can do that as an RV file. I want to save both views. I don't go for the ×2 resolution. I go for best quality. In the compression, you can go for no compression and compress it later, which may give you better results. I'll do that for now, and that will write out that animation, because the compression is quite aggressive if you use the default settings of Paraview, so it may be better to compress afterwards. If you don't know how to compress a video afterwards, obviously you'd select the compressed variant, because you need to use another tool to get this compressed. You would need a video editor. That should have written out all that data. So let's have a look where we are here. Boom, here we are. So that has written out all these. So we have the contour here. We have the graph here. Obviously, you would need to put labels on these graphs, which I can show you in a minute. We didn't do that. You have both panels and so on. And we also have the animation which doesn't play now, so I need to check that. No, that hasn't worked. The animation hasn't worked, so most likely I should have used the compression. So the animation has not worked in this. But this shows you how you can write out these images. And for titles on the axis, so left axis title would be wall shear stress in pascals, and the bottom axis title would be time in seconds. And now you have titles here. You can edit all the features of this plot in these properties, and this will give you nice plots of your data. So this is what I want to show you in this video. I'll be back with another video showing you some neat tricks, how you can reproduce post-processing sessions for different cases. And I'll be back with that in a short while.